Number 2 says that if the discriminant of the quadratic equation is 6, what statement describes the roots? So here 2, if discriminant of quadratic equation is 6, which statement describes the roots? What statement describes the roots? Okay, so here it says there's only one real root. There are 2 complex roots. There are there are 2 real roots, and there's only 1 complex root, right? So what is this discriminant, right? Remember, the discriminant here is simply, remember, our quadratic formula, right? Our quadratic formula states that it's negative b plus or minus square root of b squared minus 4ac all over 2a, right? So that's here is my quadratic equation here. And I have negative b plus minus b squared minus 4ac, right? This here is my discriminant, right? Discriminant. So if I'm saying square root of b squared minus 4ac is my discriminant, so this square root of b squared minus 4ac equals 6, or my discriminant, what does that statement describe, right? What does that say about my roots? Remember, I'm solving this x equals, right? I'm solving for something here, right? So if my discriminant equals positive in this case, or positive, or it's positive in this case, I can say that this entire thing here is 6, right? So basically, I can rewrite my quadratic equation to look something like this. So I would have x equals this negative b plus minus 6 over 2a, right? Negative b plus minus 6 equals 2a. And then what I can do is I can split this up, right? I can split this up into positive and negative, right? So I'm going to have here x would equal negative b plus 6 over 2a. And this here is negative b minus 6 over 2a. And in this case, both of these answers here will give me a real root or a complex root, or only one real root, right? In this case, I have here negative b plus 6 and negative b minus 6. These two will give me different answers, right? I'm going to have a different numerator. I'm dividing by the same denominator, but I have a different numerator, which means I'm going to get 2 different answers here. So I'm going to get two different, I'll say different values for now, which means it's either B or C in this case, right? It's either B or C, and we have to determine if these roots are complex or real, right? In this case, it's actually a real root, right? If we had a complex root, my discriminant would be an imaginary number, right? If I had b squared minus 4ac, if it were to be a complex root, this would have to equal I, or some type of value times I, or something like that, because my inside the square root here would be a negative number, right? Negative value. I'm square rooting a negative value, which means it's a complex number here. So if it's and in this case, it's just this equals 6, right? Which is not a which means I don't have a complex root, which means my answer here is I have 2. So in this case, this would be also a real roots, right? Real roots, which means my answer here is C, right? And here so this actually matches what they said here. So the explanation is discriminant of the quadratic gives us the nature of the root. That's good. We don't know if it's complex or real. It's b squared minus 4ac. That's correct here. If d is greater than 0, the quadratic has 2 real roots. That's what we had here. If it's less than 0, if it's a negative number, it has 2 complex roots. If it's equal to 0, then it has equal roots, right? It has one real. It has both my x-intercepts are the same. If d equals 6 greater than 0, hence it has 2 roots. So I like this solution. This is perfect solution, and in this case, it's the logic here, right? So this question here is correct. And this here was question. This here is question 2, right? Question 2. Solution is correct.